Imagine this. You sit down at your computer, open a blank text file, and type a single sentence. 15 minutes later, you're looking at a fully functional operating system, not a toy, not a prototype, but an Agentic OS that can manage tasks, orchestrate workflows, and even write its own code. That's exactly what Claude Opus 4.8 just pulled off. In the time it takes to brew a cup of coffee, this AI transformed a vague idea into a working digital ecosystem. No debugging sessions, no Stack Overflow tasks, no late-night coding marathons. Just a prompt, a pause, and a paradigm shift. This isn't incremental improvement, it's a complete rewrite of what we thought was possible. The old world of manual coding, where every line was a battle, is giving way to something faster, stranger, and infinitely more powerful. But how does an AI build an entire operating system in the time it takes to watch a sitcom? The answer lies in Claude Opus 4.8 Feed's ability to architect complex systems on the fly, making decisions that would take a human team weeks to debate. It starts with task scheduling, the OS's heartbeat. Claude doesn't just assign priorities, it designs a dynamic priority queue that adapts in real time, learning from workload patterns. It's like watching a chess grandmaster play 10 games simultaneously, each move calculated to optimize the whole board. Then comes memory management. Instead of a static allocation model, Claude implements a tiered memory hierarchy, caching frequently accessed data in high-speed lanes while relegating cold storage to slower tiers. It's elegant, efficient, and entirely self-designed. But the real magic is in inter-agent communication. Claude creates a messaging protocol between agents that's both lightweight and robust, allowing them to pass tasks, share results, and even negotiate resources without human intervention. In 15 minutes, this AI has done what did Linus Torvalds months. Architect a system that's not just functional but scalable, resilient, and intelligent. The old world of manual coding is dead. Long live the new one. So we have the architecture, but architecture is just a blueprint. The real test is whether it actually runs. Claude Opus 4.8 now faces the moment of truth, turning that elegant design into a living, breathing OS. It starts by writing the core kernel, a minimal scheduler that can spin up processes, manage threads, and handle interrupts. But here's where things get interesting. The first draft crashes. Spark, a null pointer exception ripples through the code, and any human developer would be reaching for the debugger. Claude doesn't panic. It reads the error, traces the stack, and in the next line of output, it rewrites the offending function with a null check and a fallback handler. It's not just fixing bugs, it's learning from them. Then comes dependency resolution. The OS needs a file system, so Claude imports a lightweight library. But that library has a version conflict with the networking module. A human would spend hours on Stack Overflow. Claude simply rewrites the import statements, patches the API mismatch, and moves on. Finally, deployment. Claude generates a Docker file, configures the environment variables, and writes a startup script that initializes the agentic core. 15 minutes in, the OS boots. No errors, no manual tweaks, just a prompt, a pause, and a production-ready system that can schedule tasks, manage memory, and orchestrate agents. The line between idea and execution just vanished. Now let's talk about what this means for the enterprise. Because when an AI can go from a blank text file to a working operating system in 15 minutes, the entire concept of delivery timelines gets thrown out the window. Think about your average project management office. Right now, if a team wants to prototype a new workflow automation system, they're looking at a 2-week sprint minimum, requirements gathering, architecture reviews, coding, testing, deployment. That's the standard, but Claude Opus 4.8 just collapsed that into a single meeting. A PMO could walk into a morning stand-up with a vague idea, describe it to Claude, and by lunch have a fully functional agentic OS orchestrating their task force, managing dependencies, and generating reports. The bottleneck isn't development anymore, it's decision-making. Engineering teams can now iterate on production systems in hours, not weeks, which means portfolio execution becomes a real-time process. You don't plan for next quarter, you deploy this afternoon. And that changes everything about how organizations allocate resources, manage risk, and deliver value. The old project lifecycle is dead. Welcome to the era of instant infrastructure. And that brings us to the real conclusion, the new operating model. Because when an AI can generate a fully functional agentic OS in 15 minutes, we're not just talking about faster coding. We're talking about a fundamental shift in how organizations operate. Think of it as a new intelligence layer that sits between raw data and executive decisions. In the old world, leaders had to wait for reports, dashboards, and manual analyses to understand what their systems were doing. But now, with an agentic OS built on the fly, those systems can generate decision-ready signals in real time. OS itself becomes a sensing organ for the enterprise. It monitors workflows, detects bottlenecks, predicts failures, and surfaces actionable insights without any human intervention. This reduces fragmentation because there's no more siloed data or disconnected tools. Everything is orchestrated by a single, adaptive intelligence. And it reduces systemic risk because the OS can self-correct, reroute resources, and even rewrite its own code when something goes wrong. The leaders who embrace this won't just be managing projects. They'll be piloting a living system that learns and evolves with every transaction. The Agentic OS isn't just a tool, it's the new operational backbone of the enterprise.